Thinking and problem solving. Theories of thought processes. Associationism. The philosophical tradition of associationism can be traced back to Aristotle, but it developed mainly from the 17th to 19th century through the effort of scholars, mostly who were interested in the origins and nature of human knowledge. Warren, 1921. Associationism is a theory about how items combine in the mind to produce thought and learning. Important exponents of associationism include Thomas Hobbes, 1588 to 1679, David Hartley, 1705 to 1757, E. Tene Banotti Condillac, 1715 to 1780, James Mill, 1773 to 1836, Thomas Brown, 1778 to 1820, John Stuart Mill, 1806 to 1873, Alexander Bain, 1818 to 1903, and Herbert Spencer, 1820 to 1903. Associationism can also be found in the philosophical works of John Locke, 1632 to 1704, George Berkeley, 1685 to 1753, and David Hume, 1711 to 1776. Current forms of associationism assume that complex psychological units are built from simpler elements on the basis of experience and through a process association that is both general across domains and structured independent. This process is typically sensitive to coincidences, correlations, or statistical dependencies among events, and the psychological units formed on its basis come to reflect such dependencies. To uncover the psychological principles, the associationist philosophers use the introspective method and the phenomenological investigation of thought sequences. Anderson and Bower, 1973, define associationism in terms of four basic assumptions. First, psychological units are connected by experience. Two, complex units can be reduced to a limited stock of primitive units. Three, these primitive units consist of sensations. Four, units combined through simple additive rules. According to Fodor, 1983, associationism includes a set of basic elements out of which more complex structures are built, a relation of association defined over these elements and structures, principles of association whereby experience determines which structures are built, and theoretical parameters of the associative relation and its terms. The basic tenets of associationism are quite easy to understand. Items are associated in the mind through experience. These items are derived from experience and combined to form thought. For example, a small child learns not to touch an electric wire because that child associates the wire with electric shock, the electric shock coming from past experience. Each item can combine with other items to form a more complex idea. There are four typical principles of associationism, the three main processes. The principles state that atoms that are contiguous in time or space are linked by association, that atoms that are similar are linked by association, that items that contrast are linked, and that items that have a cause effect relationship are also linked. These linking are all occurring through the three processes of sequencing, compounding, and decompositioning. Sequencing refers to a type of chronological pattern where as compounding refer to the building up and breaking down of items respectively. Information processing. While cognitive psychology is the dominant school of thought today, the information processing approach is the dominant view within this area. The information processing theory is associated with the development of high speed computers in the 1950s. Researchers, most notably Herbert Simon and his colleagues, demonstrated that computer oriented information processing models could provide new insight into how the human mind receives, stores, drives, and uses information. Information processing approach is an approach to the study of cognitive development which focuses on how information is encoded from the environment cast into a symbolic form which the mind can process through a variety of mental operations to create useful outputs such as solution to a problem. In general, there are four major theories of how we humans process information: stage, approach, levels of processing theory, parallel distributed processing theory, connectionistic models. The stage model focuses on how information is stored in memory. According to Atkinson and Shiffrin 1968, information is processed and stored in three stages: sensory memory, short term memory, and long term memory. However, the major proposition in the level of processing theory proposed by Craig and Lockhart 1972 is that all stimuli that activate a sensory receptor cell are permanently stored in memory. According to these researchers, the issue is not storage but retrieval. The parallel distributed processing model states that information is processed simultaneously by several different parts of the memory system rather than sequentially as hypothesized by Atkinson Shiffrin. The connectionistic model, on the other hand, proposed by Rommel, Mart, and McClelland 1986, states that information is stored in multiple locations through the brain in the form of networks of connections. It is consistent with the levels of processing approach in that the more connections to a single idea or concept, that is, the more extensively elaboration is used, the more likely it is to be remembered. According to Siegler 1998, while there are a large number of information processing theories, all approaches share three basic assumptions. First, thinking is information. Thinking is information processing, that is, any thought process such as remembering or perceiving involves the processing of information. Two, it emphasizes the need to study the exchange mechanisms that move developments from one state to the next. 3. It includes self modifications, that is, as earlier knowledge and strategies can modify thinking and thus lead to higher levels of development. According to Siegler 1998, information processing theories focuses on the organization of the information processing system, or what he calls the structural characteristics and the processes that provide the means for cognition to adapt to the changing demands of the environment. Concept formation. Concepts are mental categories used to group objects, events, information, etc. Or we can say that concepts are mental representations that can be expressed by a single word or set of ideas described by a few words, such as plant or animal, table or chair, apple or mango. Through the use of language, individual concepts can then be connected to build more complex concepts. For example, birds fly and human walk and humans walk. There are many theoretical views of concepts, concept formation, and learning. The classical view treats concepts as entities with well defined borderlines and describable by sets of singly necessary and jointly sufficient conditions. Other view includes the prototype view, the exemplar view, the frame view, and the theory view. Each view captures specific aspects of concepts and has a different implication for concept formation and learning. In the classical view, every concept is understood as a unit of thought that consists of two parts: the intention and the extension of the concept. The intention of a concept is an abstract description of common feature or properties shared by elements in the extension, and the extension consists of concrete examples of the concept. A concept is thus described jointly by its intention and extension. The classical model clearly defines a triangle as a geometric shape with three sides and 180 degrees interior angles. Grotzer 1999 coined the term deep understanding, which means that the concepts are well represented and connected. At the neural level, it implies that concepts consist of webs of interconnected neurons that then get connected to even larger systems in the case of models or in more abstract situations, whereas deep understanding involves the ability to recall many connected concepts at once, where every single concept has a deep meaning in itself. Deep thinking involves the construction of new concepts and is almost always based on what student already knows. When a learner makes sense of new material, he is able to make connections between different concepts. Two things that are important in concept formation are context and hierarchy. A context in which concepts are formed provides meaningful interpretations of the concepts, whereas hierarchy is organized in a tower or the partial ordering in which higher level concepts depend on lower level concepts. The first level concept is formed directly from the perceptual data. The higher level concepts, representing a relatively advanced state of knowledge, are formed by a process of abstracting from abstractions. Previous research in machine learning suggests that the processes of concept formation can be divided into three distinct components: aggregation, characterization, and utilization. Aggregation is a process of collection in which instances of experiences are grouped together into a set. An aggregate represents an important collection of experience. Characterization is a process which involves constructing a description for an aggregate of experience based on individual descriptions of each member of the aggregate. Thus, while aggregation identifies important experience, characterization attempts to explicitly represent what is important about the experience. The utilization process, on the other hand, integrates the characterization or concept description with the performance element of the system. In fact, it tries to evoke the important property of the aggregate through the use of characterization, and so it serves as a test of the efficacy of the characterization process in capturing the important aspects of aggregate. Reasoning. Reasoning may be defined as a set of mental processes used to derive inferences or conclusions from premises. There are two ways of arriving at a conclusion: deductive reasoning and inductive reasoning. Deductive reasoning and inductive reasoning. Deductive reasoning, also sometimes called top down approach, works from the general information to the more specific. The brain systems that implement deductive reasoning depend on whether the reasoning problem consists of familiar versus unfamiliar semantic content. It also depends on whether a reasoning problem produces correct versus incorrect conclusions. In other words, deductive reasoning links premises with conclusions. If all premises are true, the terms are clear, and the rules of deductive logic are followed, then the conclusion reached is necessarily true. When a lawyer uses evidence premises to prove his/her case, conclusion, she is using deductive reasoning. Another example of a deductive argument goes like this: it is Friday. Kunal always wears jeans on a Friday, and therefore Kunal is wearing jeans. Inductive reasoning, also sometimes called bottom up approach, works the opposite way, moving from specific observations to broader generalizations and theories. Inductive reasoning is the process of observing data, recognizing patterns, and making generalizations from your observations. It is reasoning in which the premises seek to supply strong evidence for, not absolute proof of, the truth of the conclusion. While the conclusion of a deductive argument is supposed to be certain, the truth of the conclusion of an inductive argument is supposed to be probable based upon the evidence given. Much of geometry uses inductive reasoning, discovering that the sum of the measures of the interior angles of a triangle is 180 by tearing the angles of different triangles and observing that the sum of their measures is 180 for each of the triangles is an example of inductive reasoning. Other examples of inductive reasoning include: Swati is a doctor. Doctors are smart. Swati is assumed to be smart. Although inductive reasoning can sometimes lead to false conclusions, it can often be a useful first step in the process of applying deductive reasoning to determine whether a conclusion is true. Deductive and inductive arguments. First, induction is usually described as moving from the specific to the general, while deduction begins with the general and ends with the specific. Two arguments based on laws, rules, and accepted principles are generally used for deductive reasoning. Observations tend to be used for Inductive arguments. 3. In a deductive argument, the premises are intended to provide support for the conclusion that is so strong that if the premises are true, it would be impossible for the conclusion to be false. However, in an inductive argument, the premises are intended only to be so strong that if they are true, then it is unlikely that the conclusion is false, or the truth of the premises at best only makes the conclusion possible. Problem solving. Problem can generally be defined as an obstacle that remains perplexing until solved. Researchers have distinguished between two main types of problems, well defined and ill defined. Well defined problems have a definite initial state and the goals and operators are known, whereas ill defined problems are ones in which the solver does not know the operations, the goal, or even the current state. Newell and Seaman 1972 proposed that problem solving consists of a search in a problem space. A problem space has an initial state, a goal state, and a set of operations that can be applied that will move the solver from one state to another. One of the most important aspects of problem solving becomes one of searching for a path through the problem space that will lead to the goal state. Problem solvers will use strategies or heuristics that allow them to move through a problem space. In problem solving research, a heuristic is a rule of thumb that will generally get one at the correct solution but does not guarantee the correct solution. Heuristics can be contrasted with algorithms where application of the algorithm always guarantees the correct answer, for example, the rules of addition. A slightly more complex strategy known as hill climbing technique is an optimization technique for solving computationally hard problems, or is used to that state that looks most like the goal state. In this situation, the solver just looks one move ahead and chooses the state that most closely approximates the goal state. This strategy can be useful if it is possible to look more than one move ahead but can lead subjects astray. Another strategy is means and analysis. Using this strategy, a solver looks at what the goal state is and sees what the difference is between the current state and the goal state. In case of any blockage while execution, the solver sets a sub goal of removing the block. It means the problem solver then decomposes the difference between the current state and the goal state into another subproblem and sets a goal of solving that problem. In this situation, removing the blocked state becomes the new goal. If that subproblem cannot be solved using the current operators, the problem is further decomposed until an operator can be applied. This strategy can be applied recursively until the problem is solved. Obstacles to problem solving. When referencing an old technique that may have worked on a similar problem, one may not realize that it's not applicable. A mental set is created in which a tendency to respond to a new problem is similar to the approach to a previous problem. Another obstacle while dealing with a problem situation is functional fixedness. Functional fixedness is a type of cognitive bias that involves a tendency to see objects as only working in a particular way. However, it is not always a bad technique. In many cases, it can act as a mental shortcut, allowing us to quickly and efficiently determine a practical use for an object. Other obstacle to problem solving may be lack of specific knowledge, lack of interest, so low self-esteem, fatigue, and or drugs. Role of concepts in thinking. Concepts are one of the key elements of thinking. Concepts represent objects, activities, ideas, or living organisms. They also represent properties such as sour or brave, abstractions such as anger or fear, and relations such as smaller than or more intelligent than. Concepts enables us to organize knowledge in systematic ways. We cannot observe them directly, but we can infer them from behavior. Concepts are the bodies of knowledge that are stored in long term memory and are used by default in the higher cognitive processes: categorization, inductive and deductive reasoning, analogy making, language understanding, etc. Concepts constitute a natural kind which may develop out of your everyday experiences in the world. You may possess a natural concept of animal based on your experiences with animals. While these may involve words, they also involve visual images, emotions, and nonverbal memories. Although growing amount of evidence suggests that concepts do not constitute a natural kind, not all concepts are natural. However, some are drawn from our experiences. These concepts these concepts are referred to as artificial concepts, which are defined by rules such as word definitions and mathematical formulas. Artificial concepts are categorized by our brains in this way when they have defining features. For example, a square is a concept, and this is used to describe objects which have four right angles and four equal sides. If an object does not meet these exact requirements, then it is not a square. It is an artificial concept and is one of the easiest concepts to learn. These concepts vary in generality, thus creating concept hierarchies which organize concepts from the most general to the most specific. The ability to assimilate experiences into familiar mental categories and take the same action towards them or give them the same label is regarded as one of the most basic attributes of thinking organisms. Thank you.